In this video, we're going to learn to do polynomial division, dividing one polynomial by another. So quickly, let's just define what we're talking about. In math, terms are things separated by plus and minus. We'll talk a little more about that as we get into it. And polynomials are things that have two or more terms. And so we'll get back to that in a little bit. One other thing that I want to point out first is if you have a fraction that's negative, okay, notice I have put the negative in three different places. So I'm putting question marks here, okay. If I have a fraction with a negative on the side, can I choose to put it in the top or the bottom as well? Are they the same? Well, let's think about it. This is going to be negative 4/2. Well, 4 divided by 2 is 2. This is going to be equal to negative 2. A negative divided by a positive is always a negative. 4 divided by 2 is 2. A positive divided by a negative is a negative. 4 divided by 2 is 2. So yes, these are all equal. The point of this is, if you have a fraction that's negative, you can choose to leave the negative on the side, or you can choose to put it in the top, or you can choose to put it in the bottom. So that said, let's go ahead and do some polynomial long division. Here we have a trinomial divided by a binomial. That's not necessarily super significant. I'm just saying. When you'll see that if you remember or kind of remember long division from 6th grade or whatever it was, you're going to see this is very similar. Our method is going to be to take the two first terms. That's all we care about in the beginning. All we're going to do is look at this, and we're going to ask ourselves, what is this divided by this? So the best thing to do is take it off to the side. Let's take x squared divided by this. If it helps you do something like that, x squared means x times x. That cancels into a 1. That's the same as 1 times x, which is just x. And so we now have our answer for that first little bit. It's going to be x. So just like in long division in grade school, we would take something divided by something here and put it up here, and then what did we do? We would take this and we would multiply by whatever was out here. So I'm going to take the x times x and then the x times 2. So x times x is x squared. X times 2 is positive 2x. Okay. Then what did we always do in long division? Well, we would subtract. So I'm going to take all this and put parentheses around it, put minus in front of it, and we're going to do our subtraction. Notice that I have x squared just like I did here. Well, that's important. That's specifically what we planned to happen, because when I do this minus this, I'm going to get 0. And that's what we want. We wanted to get rid of this first term, then we're going to get rid of this term, then we're going to get rid of this term until we can't do it anymore, and then we may have a remainder, or we may not. I'm not going to put the 0 there because it doesn't really need to be there. Okay, well now I have negative x, or you can think of it as negative 1x minus 2x. Let's take that off to the side. Negative 1x minus 2x. We're really just combining like terms. That's what this is. How do we combine like terms? Well, if you had, if you had 2x plus 3x, you'd say, well, that's 5x. So what you're really doing is you're saying 2 plus 3x. Okay, well, what we're going to do here is the same thing. We have negative 1x's. We want to combine that with another negative 2x's. How many x's do we have? Well, you could think of it as negative 1 minus 2x. Okay, well, how many x's is that? What's negative 1 minus 2? Well, if you're at the origin and you go left 1 and then left 2 more, that's going to put you at 3 left. So the answer is negative 3x. And so when we do this minus this, we're going to get negative 3x. Now, what do we always do? We bring down whatever's left. We're really subtracting. I'm taking negative 6 minus 0, and that's just negative 6. In grade school, they'd say, you know, put an arrow, bring it down. Well, they don't usually point out you're just subtracting like everything else did. You know, you can think of it how you want, just bring it down. Now we're going to do it all over again. We're going to take the two first terms, this term and this term, and we're going to ask ourselves, what is this divided by this? Then we're going to put it up here, and we're going to multiply so that what's down here is going to end up being negative 3x, and it will subtract away. So what's negative 3x divided by x? Well, that's just negative 3 times 1, which is just negative 3. So now we're going to take negative 3 times x and then negative 3 times 2. Negative 3 times x is going to be negative 3x, just like we planned. Negative 3 times positive 2 is negative 6. And now we're ready to subtract again. Okay, what's negative 3x minus 3x? So let's think about that, because people forget. Negative 3x minus 3x. Well, I'm not going to go into why in this video because it'll make it too long, but anytime you subtract a negative, it's the same as adding. This is really the same as negative 3x plus 3x. Well, what's negative 3x plus 3x? Well, it's 0. If it helps, think of the positive number first. 3x minus 3x is 0. So this is 0, but I'm not going to put it there because there's nothing there. Okay, now I have negative 6 minus 6. I have negative 6, and I'm subtracting negative 6. That's the same as negative 6 plus 6. What's 6 minus 6? That's 0. Okay, so I will put a 0 here for the whole thing. So we have a remainder of 0, so we're done. What was the point of this whole thing that we just did? We were asking ourselves, what is this expression divided by this expression? And that's this expression. And you can try it. I'm not going to take time to do it here, but if you want, multiply this times this. A lot of times it's called foiling, but it's really just distributing. And if you multiply these, you will get and so you can always test that. When you do division, it's always a good idea. Once you get your answer, multiply the answer times this expression and see if you get this expression. Let's do another one. So we're going to take these first two terms, and we're going to do 3x squared divided by 3x. So 3x squared divided by, not 3x, x. And we get 3x. So we're going to put it up here. I like to line vertically like terms up. That's like I think I said before, it's not necessarily the only way, it's just my way. 3x times x is 3x squared. 3x times negative 6 is negative 18x. Now we subtract. Well, this minus this is 0. Negative 16 minus 18 is the same as negative 16 plus 18, which is the same as 18 minus 6, which is 2. So if I have this many x's and I combine it with this many x's, I'm going to have this many x's. Negative 12 minus 0 is negative 12. Okay, now we're going to take this term and do the same thing all over again. Negative 2x divided by x. Sorry, not negative 2x. I don't know where my brain is today. 2. So positive 2. 2 times x is 2x. 2 times negative 6, a positive times a negative is a negative. 2 times 6 is 12. Okay, now the fast way to think about this is 2x minus 12 minus 2x minus 12 is just going to be 0. And we are done. What do you do when you see this? Well, the exact same thing. Just write it like this. Okay, so I mean that's all there is to this. This and this are the exact same thing, but we normally do it like this so that we can do the operation of long division. There is one other thing here, unrelated to what we just talked about, though, and that is, notice that we have a power of 3, we have a power of 1, and a constant. Okay, remember, you know, for future reference, anything has a power of 1. Okay, these are the same thing. Everything automatically has a power of 1. If it helps you to put a power of 1 on there, you know, to think stuff out, then go ahead and do it. But just like, okay, if you have something like that, well, we have place values, right? Ones, tens, hundreds, thousands, and here the hundreds is empty. Well, we don't do that. We don't say, well, there's no hundreds place, so we'll just leave that blank. In the old days, they used to, like, you know, thousands of years ago, well, less than that actually, they would just leave spaces. Different civilizations have done it like that, just leaving spaces. And then somebody finally invented 0 in like the 6th century. Nobody had ever thought to have a symbol for nothing. But so anyway, that way, you know, 2046 didn't look like 246. Well, kind of the same thing here. We want a vertical column for every possible place value. And so we need to have all the powers. Normally you would want, you know, I'm just going to do a really basic one here, but you want to see all the powers down to 1 and then a constant. A constant is 1 degree less than, you know, a variable with a power of 1. So here we are missing an x squared term. We have a cubed, we need to have a squared, and then we have a power of 1 and a constant. Well, how can we change this into something that is not really changed, but it has a squared power? Well, it's pretty easy. How about if I just put a dummy term in there, 0x squared? 0 times anything is just 0. So if you look at this, you'll see this is exactly the same as this. But now we have that vertical column for the power of 2. So whenever you are missing a power, you need to always check for that. You need to put in as many as you need to have descending powers from whatever the highest one is all the way down to constant level. Okay, so now let's go ahead and do this. So as usual, we're going to take the first two terms. X cubed divided by x is x squared. I'm just going to start doing this faster now. So we're going to put x squared in. Again, I like to line up vertically all of the like terms. Okay, now we do our multiplication. X squared times x is x cubed. Negative 3 times x squared is negative 3x squared. But notice I had a column that I could put that in now, whereas before I wouldn't have had. We do our subtraction. Obviously this one goes away. Then we have 0x squareds, and from that we minus negative 3x squareds. So if we have 0 minus minus 3, that's the same as 0 plus 3, which is just 3. And so we have 3x squareds. 3x minus nothing is 3x. 6 minus nothing is 6. Okay, we start it again. So 3x squared divided by x is just going to be 3x. So that gives us, not really sure why I changed colors there, but I'll leave it. Okay, negative 3 times positive 3 is negative 9. Okay, this one goes away. Here I have 3 minus 9. That's the same as 3 plus 9. That's how many x's I have. I have 12 x's. Okay, now notice here that the degree is the same here and here. The degree of any expression is the number of the highest power on a variable. Okay, well here they're both 1. That means they're the same degree. Notice we had a higher degree, lower degree, lower degree, same degree between here and here. When you have the same degree, you can do one more round. Once this degree drops below this, you have a remainder. There's nothing else you can do, so you take it as a remainder. So we can do this one more time. So 12x divided by x is just 12. Okay, 12 times x. Negative times positive is negative. 3 times 12 is 36. We subtract. This goes away, and then 6 minus 36, the same as 6 plus 36, which is 42. Notice now this is a constant, this is a variable. The constant is a lower degree. We cannot do any more division. That means this thing here is a remainder. So what do we do with a remainder? Okay, well, let's go off to the side here and remember that when we did ordinary long division, let's see, I don't want to do that. Let's do 3. Okay. Well, here I have a remainder. First or second or third graders do this, remainder 1. Well, actually, probably not first grade. I'm not sure on that. But what do we always do when we don't put remainder whatever anymore? Well, we make a fraction. The remainder always goes over this number right here, the divisor, into a fraction. It's the same exact thing we're going to do with this thing. We're going to say 42 over, and then this here, it's going to be over that. X minus 3. Okay, and so that's obviously added to this, and this is our answer. It looks messy. Looks even weirder now that I just arbitrarily switched colors. Not sure why I did that, but what the heck, it's kind of fun. Okay, on this one, pretty much business as usual. We have all of our powers. Always check that. I have a power of 3, power of 2, power of 1, and a constant. So everything's accounted for here. Here we have a squared power, power of 2. We're missing a power of 1, and we have our constant. Now, some people actually would write this, they'd write, they would write this out here. That's not as important. I don't bother doing that myself, but you can if you want. It might not be a bad idea, but it doesn't really hurt anything. You'll see how it develops anyway. But this one definitely has to have all the powers accounted for from whatever the highest one is down to the lowest. This one, not that important. Okay, so let's go ahead and do this. So 2x cubed divided by x squared. Again, we're just, as usual, doing the first two terms. Okay, if it helps you do this, you get where you don't have to do that with experience, but if that helps you, go ahead and do it. Okay, and so we have an x term, so I'm going to write it above the x term down here. Okay, 2x times x squared is going to be 2x cubed. That's what we planned. 2x times negative 3 is going to be negative 6x. Notice I didn't write it here. I wrote it under its like term. Okay, if we had had that dummy 0 term out here, then we would have ended up, having a 0 term here. But I just leave a blank there. It doesn't hurt anything at all. That's why I don't think it's important to rewrite this with dummy terms. It is this, not so much this. Okay, we do our subtraction. So this goes away, and then I have negative 5x squared minus nothing. So that's just negative 5x squared. Then I have this many x's minus this many x's. So I have negative 3 minus 6. That's negative 3 plus 6. And that's how many x's I have. Negative 3 plus 6 is 6 minus 3, which is 3. That's positive 3. That's how many x's we have. And then 7 minus nothing is 7. Okay, so we've got one round done. Okay, I need to do it again. Notice this is the same degree. This is a squared term, squared term. So we can only do this once more. So negative 5x squared divided by x squared is negative 5. Okay, negative 5 times x squared is negative 5 times x squared. Negative times a negative is a positive. Actually, that's going to go out here. 5 times 3 is 15. I had some technical difficulties there. Okay, now it's on red. That's fine. We'll just go with it. Okay. So negative 5x squared minus 5x squared is the same as negative 5 plus 5. That's going to be 0. This goes away. 3x minus nothing is 3x. 7 minus 15. Now, think about it. 7 minus positive 15. 7 minus positive 15. Well, positive just means combine it with. I'm taking a 7, and in other words, this really, it doesn't do anything. It's the same as 7 minus 15, which is negative 8. Okay, so just think about this a little bit. 7 minus a positive 15 just means 7 minus 15. Think about that a little bit till you're satisfied that that makes sense. Okay. Now notice this is 1 degree less than this. That means we cannot keep going. We're not going to take 3x and divide it by a higher degree thing, because that's just going to make a mess. There's nothing mathematically wrong with it. It just would make a mess. It's not worth it. So this now becomes a remainder. So that's going to come up here. Remember, the remainder always goes on top of a fraction. And whatever's out here, the divisor, is going to go on the bottom. And this is being added. If this had like, a negative in front of it, we would put a negative sign here. But it doesn't. So it's just positive, and we are done. This is messy looking, but that's the answer. 2x minus 5 plus 3x minus 8 over x squared minus 3. And if you were to multiply this times all of this, you would get this. Okay, on this one, remember, we're going to write it in the form that we normally do long division. So this is going to go in here. This is going to go out here. I'll write that first. Okay, but this is going to go in here. Before I put it in here, though, I need to add several dummy terms because I have a power of 4. I'm missing a 3 power, a 2 power, and a 1 power before I get to my constant. So I need to put that many dummy terms in. Okay, then we just proceed. X to the 4 divided by x squared is going to be x squared. X squared times x squared is x to the 4. X squared times 2 is positive 2x squared. I'm going to stay with the same color here. All right, this goes away. 0 minus 0 is just 0, so we don't put anything here. 0 minus 2 is, okay, 0 minus 2 equals negative 2. We have negative 2x squareds. Okay, I'm going to bring this down. And we're going to do it again. Notice we're the same degree now, a degree of 2. So we can only do this once more. Negative 2x squared divided by x squared is negative 2. So I write it above its like term. I multiply this. I get negative 2x squared. Negative times a positive is a negative. And 2 times 2 is 4. This goes away. Negative 2 plus 2 is 0. We have 0x squareds. There's nothing here. 0 minus nothing is 0. There's nothing here. We have negative 6 minus 4. That's negative 6 plus 4, which is the same as 4 minus 6. Negative 6 plus 4, 4 minus 6 is negative 2. Okay, now we can't go any farther. This is a remainder. So we're going to take our remainder up here, and then this is going to go on the bottom. Okay, and let me write the answer out here so it doesn't have this space. So our answer is x squared minus 2. Now remember, at the first of this video we talked about if I have a negative in a fraction, I can choose to have it in the top, on the side, or in the bottom. Well, this looks weird. If I do okay, that just looks weird. So we would normally put it on the side. So if you have a negative remainder, that's what you're going to do. You're going to have a negative in front of your fraction. And this is our solution. Okay, last example. I know this has been kind of a long video, but you kind of have to see quite a few examples to see everything that's going to happen. This looks big and scary, but we're going to do the exact same thing. Nothing's changed. I already filled in a dummy term here. So we have 4, 3, 2, 1 in a constant. So we have all our descending powers. And as usual, we're just going to take our two first terms. We have 3 terms here. That doesn't change anything. There could be 50 terms here. That would be a nightmare. But anyway, you're still going to take the 2 first terms. That's all you care about. So we're going to take 6x to the 4 divided by 3x squared. That's 6 divided by 3 is 2. X to the 4 over x squared is going to give us x squared. And so we have 2x squared. Okay, now we have to take this times all of this. We're going to do 3 multiplications because we have 3 terms. We're basically distributing this. So I have 2 times x squared times 3 times x squared. That's going to be 6x to the 4. Okay, now I have to do this middle term times this. That's going to be positive 3 times x times 2 times x squared. That's going to be 6x cubed. And then I have a last term here. Negative 4 times positive 2x squared is going to be negative 8x squared. Now all of this is going to subtract. Obviously this goes away. 0x cubes minus 6x cubes is going to be negative 6x cubes. Okay, then I have negative 11x squared minus 8x squared. So negative 11 minus 8 equals 11 plus 8. 8 minus 11 is negative 3. So I'm going to have negative 3 x squareds. Then I just bring both of these down, and we do it again. I'm a degree higher, so I can keep going. So negative 6x cubed over 3x squared. That's going to be negative. A negative divided by a negative is a negative. 6 divided by 3 is 2. X cubed over x squared is x, so we have negative 2x. And now I have to take this negative 2x times all three of these terms here. So positive times a negative is a negative. 3 times x squared times 2 times x squared is going to be 6x cubed. Okay, now this middle term times this. Again, that's going to be negative. 3 times x times 2 times x is 6x squared. Then I have negative 4 times negative 2 times x. That's going to be 8x. Obviously, this goes away. Then I have negative 3 minus minus 6. That's negative 3 plus 6. That's 6 minus 3. That's 3x squared. Then I have 11 minus positive 8. Well, 11 minus 8 is 3. Now I bring down the negative 4. Okay, and we do this. I have the same degree now, degree 2. I can do this once more. 3x squared divided by 3x squared. Well, anything divided by itself is just 1. So now we do 1 times all of this. Well, that's easy because 1 times anything is just the thing. So I can just write this all out here. So 3x squared plus 3x minus 4. And we can see there's going to be no remainder because it's the same thing. When we subtract it, we are going to get 0, and we are done. This thing times this thing equals this thing. I recommend that you go through each example in this video and practice doing the same exact thing without looking. That's the best way to learn math initially, is take something you just saw done, try to do the exact same thing without looking, and you will quickly get a handle on this.